Hello everyone and welcome back. So let me save this scene as 6 live. Name it 7 live. Okay, and what I'm gonna do is I'm gonna subdivide the geometry a few times. Okay, so this is our new geometry. And we're gonna work on this one. So if we go all the way here, we have our displacement. And let's use a color. Or yeah, that's fine. We'll turn off the turn on the color visualization here. And then if we take a look, we're adding the displacement that we want. Okay, so maybe we can go a bit more, something like this, without causing a huge deformation to the mesh. Something like this. Okay, so this is our high-res geometry, but now we don't have any UVs anymore, or the UVs are distorted. So let's do a UV quick shade node and visualize what we have. And I'm going to turn off the coloring here. And I'm going to put down a color node. And this is our mesh. If we look before the displacement, we should see no issues. Okay, so what we need to do now is we need to fix the UVs on this mesh. And the easiest way to do this is by using something similar to what we wanted to do at render time, but in the scene. So we're going to take the new position of these points and use them to do a lookup on this mesh. This is our original mesh. It's perfect. It doesn't have any issues. But I don't need this high-res version. I actually need only the original raw data. So this is the box that we started with before fracturing, before anything. Okay, so this is our mesh. And let me fix that. Let me increase the attribute transfer here. Maybe 4. I don't need any displacement there. 5. And here I'm going to make sure that I'm transferring only the CD color. This is for the edge. I'm not using the masks at the moment. We'll add them later, but let's solve it as if everything is getting displaced. Okay, so this is the mesh, and we want to fix or restore the UVs. Now we cannot use an attribute transfer because the result won't be ideal. Okay. And the easiest or the most stable solution is to actually use a ray casting, is to shoot rays from each point and have them intersect with the geometry and do a UV lookup. The attribute transfer works great if we have a lot of points, but here we don't. We only have flat surfaces. So we need to shoot rays onto the geometry like this, and then whenever they hit something, we need to query what the UV attribute is in that location. And to save us some time, I know we're going to run into problems, and you probably guys have gotten to this point but failed to get the UV to transfer nicely. And the reason for that is because we need to be working in UV space, in vertex mode. If we do any of this process in UVs as point attributes, it's never going to work. So we need to create a point VOP and set it to vertex attribute. Okay, so here I have a UV, it's a vertex attribute. Here it's a vertex attribute, and it needs to stay a vertex attribute. So I'm going to plug in this first input. I'm going to plug in the second input here. And what we need to do is we need to use this new position and say, okay, what is the closest point to you on this mesh? Which point do you intersect with? And let's dive inside. We're going to use an intersect node. and you can see that it has a ray origin. So the ray origin is going to be our newly displaced point. Okay. And it needs a direction. So we have the point. Let me put down a color. So we have a point, but we don't have anything to shoot along. Well, we could use the normals. Okay. We could use the normals to do that, but not in it's not going to be always the case where the normals are going to be pointing in the right direction. So what we need to do is we need to find the closest point on the from this point onto the next geometry, onto this one, and this way it's going to find the closest vector that takes that point onto the next mesh. And what we can do this using a min position, minimum position. And this will take a current position, a second input, and it will tell you where is the closest position from A to B. So I'm going to plug this in, and this, the up input is going to be the second. I'm going to plug this into the N, and right now if we look, you see everything is pointing in a wrong direction. Now why is that? Well, the reason for that is because both of these meshes are overlapped on top of each other correctly, so there is no room for these rays to travel along. It's identical, it's 100% the same. So what we need to do is we need to peak the geometry to add a tiny bit of padding. I'm going to use 0.01 in this case, and maybe that's too much, 0.04. So from here to here, see, I just made a small gap, and now if I look at this mesh and template this, we should see a small gap. You see it there. Okay, so now if we look and display the normals, why is it primitive? It should work. Okay, let's see. I'm gonna, oh, I know why. Yeah, because the normals is vertex attribute. So I'm gonna promote that from vertex into point, and now it's displaying the result that we created, but I'm not so sure why it's pointing like that. Okay, let's verify. Let's make sure. Okay. Okay, we'll try it and see what we get. So as long as maybe it's just a display issue, and let's use this information. So oh, I know why. Sorry, this is correct. What this is giving us is the new position. So it's not a normal. It's not querying anything. Sorry about that. What we need to do is we need to subtract this from this. So this is the new position on where that point hit the surface, the other surface, and if we subtract the two and normalize the result and plug it into the normal and display the normals, you will see that it's working. See? So that's our vector, and if I invert it, it's pointing that way. So this is the most efficient way to compute the best direction that we can shoot these rays along. And I'm going to plug it into the ray direction. And now when we're going to shoot rays, they're going to follow this direction, and then the origin is going to be P, and if the result is good, it's going to give us back a primitive, okay, and also a UV coordinate. And what I need to do is we need to use that information to query certain attributes from the mesh. And the attribute is going to be queried using a primitive attribute node. So this is not a import point, sorry, this is not a import attribute. This is going to look up attributes based on their primitive number and their UV space. It's like a UV lookup that I wish we had at render time in Arnold or other engines. In Mentra it is. In Mentra this is easy to fix. So I'm going to use the prim UV. The prim number is this, and then the UV coordinate is this. Now if I plug this, if I bind export this data as UV, and it's a free float or a vector, and we need to tell this the primitive attribute that we want to import the UV attribute. Okay, I'm gonna disable delete that, and if we view quick shade view this, we should see the result. Okay, let's see why is this. So there's that. There's that. And the reason is because we need to invert this result. Oh no, sorry. We need to connect this file as well. And bind export this. This is good. And there it is. So this is the direction, this is the ray origin, and we have to make sure that I plug in something in the intersect, and then we're using the result. Once we get an attribute, it gives us back the primitive and the UV coordinate. We use this information to do a lookup, and this is what the lookup is giving us. Now if we bind export that, we are fixing our issue nicely. Now you will see that there is a bit of issues here around the edges, and that's because those points are not finding what something to hit, and it's only happening in the edges. If we look everywhere else, it's perfectly fine. So this is our original mesh, and this is after the fix. And if we could only mask it the same way that we're masking the displacement, because we don't want to mask or change the attributes of anything that was not affected. So if we go back here, let's make sure that the displacement is happening only in the areas that we want. Okay, and what we need to do is we have this attribute, but unfortunately it's not accessible here because this is a vertices this is a vertex point vol, and what we need to do is we need to promote the mask, which we are creating. Let's create it here. So let's create a mask attribute. Okay, I'm going to promote this into a vertex attribute because otherwise I won't be able to read it. So I'm going to call it mask from point into vertex. First match, I'm going to change the new name so I can keep the old one, and I'm going to say mask V, and it's a vertex. Now I can import it. Import point attribute. Import a vertex attribute. Import a point attribute, because now, because of the context, we're importing the point at the vertex attribute now, because this is running in a vertex mode, and each point is going to be pointing at a vertex. And I'm going to use this to mix between the current UV with the new UV. And I'm going to use this attribute, and then this is going to go here. And if we look at the shade now, everything should be fixed. Not that much. It is doing something. Actually, we don't, sorry. I got so confused. We just need to bind this. Bind import, and it's going to reference the correct attribute. And it's a mask V, sorry, not mask. See, it fixed because now it's binding, bind importing the vertex attribute. And by doing that, it's perfectly fine. And we have to be very careful because mixing in points and vertices is going to be the main cause for these type of issues. And now we have our mesh fixed, and if we can fix or clean up the geometry and make sure that we only have data where we need them, because not everything needs to be high res, so we only need to capture or keep the resolution and the boundaries. And if we do some cleanup, I think it would be great for overall to save and optimize the geometry. And the last thing is, we don't need to do all this after the transform. Okay, we only need to do this after the transform and transform the vectors and all, if we're planning to use the triplanar method or do the displacement at render time. But as you saw, with that technique, we can't fix the UV issues easily. So this way, I don't need to do this here. I only need to transform this. And if we look at the UVs and play this through, let me change this to flat shaded. And yeah, flat shaded. And then if we hit play, everything is working as expected. Now the interior, we don't care too much about unless we need to, unless we have specific UVs, which I've rarely seen. It's generally a triplanar and you map a tile texture. The other thing is we don't need to do this for the interior faces. We can only apply it to the exterior, so we can isolate blast inside and then outside, and then merge both, so we don't change the UVs on the interior faces. And we didn't have it, so it's fine. And this way we have a perfect mesh, no more issues. It's only the overhead of doing the displacement in the scene, and we're going to take a look at how we can make this very efficient next week. Thank you guys for watching, and see you in a bit.